everyone. Today we'll do the applications of Gauss theorem. The first application is electric field due to a hollow sphere. So we'll consider a hollow sphere of radius r. This is radius r and charge q. The charge on this sphere is q. Now we'll do this in cases. So we have case 1. We'll find electric field outside the shell. So we'll take a point at r distance from the center. And this is the surface that we get. We'll consider this point as P. We will find the electric field in this region. So this is the unit vector in this direction. The electric field is also in this direction. So we'll apply Gauss law to find out the electric field. So as we know, integration of E dot ds is equals to q upon epsilon naught. So as we can see, electric field and the unit vector are in the same direction. So we'll write it as E ds cos theta is equals to q by epsilon naught, and E ds cos 0, as they are in the same direction, is equals to q by epsilon naught. So we get E integration of ds is equals to q by epsilon naught. Now the area will be, the surface area will be 4 pi r square for a sphere is equals to q by epsilon naught. We can write E is equals to q upon 4 pi r square epsilon naught. Now to simplify the formula more, we'll also write the n vector here for the direction. So to simplify the formula more, we know the surface charge density is equals to q by 4 pi r square for the hollow sphere. So q is equals to sigma 4 pi r square, capital R square, the radius of the hollow cube. So we can write E is equals to sigma 4 pi r square upon 4 pi r square epsilon naught. 4 pi and 4 pi gets cancelled. So we get the electric field as E is equals to sigma capital R square upon R square epsilon naught. This is the electric field for outside of the sphere. Now we'll take case 2. Case 2. If point P lies inside the sphere, lies inside. So this is the sphere of radius r, and if the point P lies inside, if it lies here, so this is the area, the electric field is in this direction. So E dot ds is equals to Q enclosed upon epsilon naught, and E dot ds will be equals to 0 upon epsilon naught, as the charge inside the sphere is 0, as it is a hollow sphere. So the electric field turns out to be 0. Now, case 3. If P lies on the surface of the sphere, then we know E is equals to sigma r square upon E naught r square, small r square, that was the radius. And if the P lies on the surface, so R, capital R is equals to small r, then R is equals to R, then the electric field becomes sigma upon epsilon naught when P lies on the surface of the hollow sphere. So we have done 3 cases: when P lies outside, when P lies inside, and when P lies on the surface. So this is the answer. Thank you, and we'll do the rest 2 applications in the next video.